Hello GCC, how are you doing? This is the Chapter 2 fourth video for Chem 130. We just learned that when you add and subtract, you focus on decimal places. However, when you multiply and divide, we focus on sig figs. So for multiplying and dividing measurements, your final answer has to have the same number of sig figs as the least sig figs. So it's the least again, but not decimal places, total sig figs. For example, 3.546 meters times 1.4 meters. Let's try that on our calculator. 3.546 times 1.4 equals, I get 4.9644. So 1, 2, 3, 4, 5 sig figs. Wow. Let's look at how many I started with. 3.546 has 4 sig figs. 1.4 has 2 sig figs. So I started out with 4 and 2 sig figs, and I ended up with 5. That's even more. How can I get more significant just by multiplying? Well, I can't. So we have to be as accurate as the problem. And the problem is 1.4 is the least accurate number in the problem. 2 sig figs. So I'm going to have to round that 4.9644 to 2 sig figs, which happens to be 5.0. Also look at the units. Meters times meters is meters squared. Yeah. So final answer, 5.0 meters squared. 2 sig figs, since 1.4 in the problem is 2 sig figs. We focus on sig figs when we multiply and divide. The calculator doesn't do sig figs. Okay, you have to do sig figs. Let's try another one. 47,500 feet times 1.45 feet. Let's try that in the calculator. 47,500 times 1.45 equals, again, it's a big number, 68,875. 5 sig figs. Okay, but we have 1.45 feet in the problem. That only has 3 sig figs, so we have to round to 3 sig figs. So again, we got 68,875 feet squared, because feet times feet is feet squared. But we need 3 sig figs. Round that number to 3 sig figs. What do you get? I hope you got 68,900 feet squared, not 689. Again, we have to keep the magnitude the same. So we need to use our placeholder zeros to keep the magnitude the same. The answer is 68,000. It needs to say 68,000. Okay, so again, focus on sig figs when we're multiplying and dividing. Now I'll tell you something. In lecture, we're going to multiply and divide a lot more than we're going to add and subtract. So mostly we're going to focus on those sig figs. All right, scientific notation, new topic. This is a convenient method for expressing very large or very small numbers. For example, look at those 2 numbers. What if I said to write those down? Do you think you'd get it correct? I mean, you're sitting there staring at the screen, 0, 0, 0, 0, 0. I mean, that's really hard to write those numbers down. They're ridiculously big or small. Top one's big, the bottom one's small. There's got to be a better way to write numbers like this, and there is. Scientific notation. Let's start with large numbers. Left for large numbers. The distance from the Earth to the Sun is about 93 million miles. Now that has a lot of zeros. It's a big number. So we're going to take the decimal point, which is at the end of the last zero, and we're going to move it to the left. It's a large number. We move to the left for large numbers. So it's after the 0. We're going to move it 1, 2, 3, 4, 5, 6, 7 times to where it's after the 9. Why there? Well, in scientific notation, you have to have 1 digit, then the decimal point. 1 digit, then a decimal point. So we have to put that decimal point after the 9. So 9.3 3 times 10 to the 7th. The 7th is because we moved it 7 places to the left. What happened to the zeros? Well, it's interesting. In scientific notation, we only show the sig figs. The placeholder zeros go away. So this is the only time we don't show placeholder zeros is in scientific notation. So if you look at the number 93 million, it only has 2 sig figs. Those zeros are keeping the place for it to be a big number. So they go away, and we get 9.3 times 10 to the 7th miles when we put it in scientific notation. Again, we need to have 1 digit, then the point. Engineering notation is wrong, which is 93 times 10 to the 6th. I understand it's the same number, but that's called engineering notation, and this is not an engineering class. It's a science class. So we're going to do scientific notation. All right, I hope that makes sense. Moving on. We're going to write numbers in scientific notation now for small numbers. We move the decimal to the right for small numbers. So the radius of a carbon atom is about, oh boy, 0.0000000017 meters. Goodness, that's a lot of zeros. So again, there's got to be a better way to write this number. So we're going to move that decimal to the right to where we have the 1 digit before the decimal. So that means we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1.7 times 10 to the negative 10 meters. Negative because it's a small number. So if you have a times 10 to the negative number, that means it was a small number, that we had a bunch of zeros in front. When you have a positive exponent, it means the placeholder zeros were in the back, like 93 million. The zeros were in the back for the previous example. So a negative exponent when it's a small number. Again, we want to have 1 digit, then the point, 1.7 times 10 to the minus 10th meters. All right, cool. I want you to hit pause and put these numbers in scientific notation yourself. Good luck. Again, especially if this is an online course, this is your lecture. You need to hit pause, practice, and write these numbers down on scratch paper and give it a try. Okay, this is the only way you're going to learn in the online course is if you do hit pause and try these on your own. Good luck. Okay, we're back. So we're putting these in scientific notation. Number 1, 54,800 inches. That's a larger number. So we're going to move the decimal point to the left. So it's at the end of the number after the 0. So we're going to move it 1, 2, 3, 4. 5.48 times 10 to the 4th. 5.48 times 10 to the 4th. Cool. Number 2. 68,100,000 is a big number. Meters is the unit. So it's a big number. So again, we're going to move that decimal to the left. Starting at the 0, 1, 2, 3, 4, 5, 6, 7 places. So 6.81 times 10 to the 7th meters. Good job. Number 3, little number. 0.0000403 pints. PT is pints. So that's really small volume. So we're going to move that decimal place to the right, and we're moving it 1, 2, 3, 4, 5, 6 times. 4.03 times 10 to the minus 6, right? It's a small number, so we get a negative exponent. The last one's tricky, 2,000 grams. It's a larger number, so we're going to move the decimal to the left. So we're going to move it 1, 2, 3 times. But those zeros are all placeholders, not significant. So it's just 2 times 10 to the 3rd. It's not 2.0, which a lot of people do. It's just 2 times 10 to the 3rd grams. All right, let's check our answers. 5.48 times 10 to the 4th inches, check. 6.81 times 10 to the 7th meters, check. 4.03 times 10 to the minus 6 pints, Check. 2 times 10 to the third grams, check. Again, note, scientific notation always shows the sig figs, not the placeholder zeros. Placeholder zeros go away. All right, let's move on. Let's put a scientific number in our calculator. Okay, we're going to put in the number 2,390,000,000 in scientific notation on our calculator. So it's 2.39 times 10 to the 9th. So I'm going to show this on a TI-30XA. You punch in 2.39. Then you're looking for the EE button. Do you see it on my example up there? The EE button, it's right above the 7. That means times 10 to the. Don't hit times 10 to the. Use the shortcut EE button. So EE, then just hit 9. And now you have 2.39 with a little bitty 9 in the corner. Awesome. Again, do not type in times 10 to the. That's what the EE shortcut button is for. If you actually hit times 10, it's going to be wrong when you do calculations. Okay, some of you may have this calculator. It's a TI-30X2S. So for this one, the EE button is above the 7, but it's above the button, which means you have to hit the second function to get to it. So you're going to punch this in, 2.39. Go up to the upper left and hit the blue second button. Then you can hit the x to the -1 button that has EE above it. And then hit the 9. So 2.39, second function EE 9. This is the TI-30X2S. So for a calculator, you do need to have your own scientific calculator. I've just shown you 2 examples, the TI-30XA and the TI-30X2S. You may not use graphing calculators in class, on quizzes or exams, department rules. You also can't use your phone as a calculator in class, on quizzes or exams either. So again, the 2 examples I've shown you, this one, the TI-30XA, is a great calculator if you're a nursing major and you're not going to take any other chemistry courses. However, if you are moving on in chemistry and plan to take Chem 151 and 152, this one is a much better bet. TI-30X2S. I would buy that one if you plan to take Chem 151 or 152. All right, we're going to stop this video there. We got one more to wrap up chapter 2. It'll be a short one. Check you later, GCC. Bye-bye.